In this profile, the vegetation is dominated by shrub mopani, which is typically in a 2 to 3 meter range. And there's also some mopani and acacia trees that typically are in the 4 to 6 meter height range. Something that scientists need to understand and quantify is where carbon is being taken up and where it is already being stored. Because much of the effort related to mapping global biomass has been really focused in the tropics, where the trees are large and the biomass is high, many of these savanna and woodland ecosystems tend to get neglected or are poorly characterized in global carbon accounting efforts.
Okay, welcome everyone. My name is Brian Campbell, and I'm the lead for the Trees Around the Globe Student Research Campaign. And today we have a special guest we're going to talk to. This is Dr. Sorin Popescu, and he is a researcher and professor in an ICET-2 mission. As you all know, all about ICET-2, he is a principal investigator with the ICET-2 mission at Texas A&M University, Ecology and Conservation Biology. Dr. Popescu, thank you so much for being here. Can you tell us a little bit more about yourself?
Sure. Thank you for having me over. So my name is Sorin Popescu, as Brian mentioned. I'm a professor at Texas A&M University, the Department of Ecology and Conservation Biology. And here is where I teach and pursue research in remote sensing with the focus on vegetation three-dimensional characteristics with both active and passive sensors. But the most research area is using LiDAR, three-dimensional structure measurements that we can obtain from LiDAR to assess various ecological parameters, vegetation biophysical parameters, such as dimensions, first of all, and then relate those to carbon, biomass, surface and canopy fuels, and ultimately involve remote sensing to better characterize the vegetation role in the terrestrial carbon flux.
Excellent. And I know I heard you mentioned LiDAR. And for folks, we're talking basically about measuring things from space on Earth, measuring height using lasers. And it's amazing everything you just mentioned, the information we can get from data coming in from laser pulses. So it's just really amazing to see that just, you think of a simple laser beam is very actually can produce some complex data and some great results. So, and I know you work with the ICET-2 mission. You mentioned you work with vegetation, trees, forests, things like that. And with ICET-2, when you decided you were going to work on ICET-2, what are some of like the thought processes that popped up in your head, like visions you had about what you'd like ICET-2 to be able to do based upon your research interests?
Yeah, very good question. So to answer the question, probably I need to go back a bit and talk about my initial involvement with LiDAR. So with ICET-2, I've been involved since 2014 as a member of the science definition team, which later evolved after launch into the science team. But my involvement with LiDAR starts earlier than that. Actually, in 1998, when I participated in a NASA graduate student summer program at Goddard, and that's when I got the first hands-on experience with the LiDAR data set and airborne LiDAR data that fascinated me for the first time to see trees in a digital 3D model. And that's when my vision sort of emerged about the potential of tree measurements, vegetation measurements with LiDAR, and what advancements in vegetation science that could bring. So after that, I pursued my research initially in plot to local scale measurements with LiDAR, but I realized that those LiDAR acquisitions from the airborne LiDAR, were expensive at the time. So I thought it is so nice to use data like Landsat, for example, from space that's available at the time you want to investigate it. It's affordable and covers a wide area from local to regional and global. So as such, my vision was to maybe one day have spaceborne LiDAR for vegetation studies that was affordable, provided up-to-date observations, and allowed us to scale from plot to local to regional and then global scales. And I was excited in 2003 to see the first ISAT mission with the glass instrument. So that's 21 years ago, almost to the date when the first ISAT mission started collecting data. But the next one that really excited me was ISAT-2, that improved on the LiDAR technology. It's a photon counting LiDAR from space. So it's a pretty amazing technology to think about being able to count photons of the laser light that get returned to the satellite. It has a much better footprint size and sampling design for vegetation studies. And I also got to be at the launch, which was a very exciting time. But the excitement was not over with just the launch. Then in 2019, we got to visualize the first vegetation profile from ISAT-2, and the on-orbit data really looked fantastic. We were a bit nervous to see the first data from space, photon counting LiDAR, but it looked great. And to these days, it proves to be extremely useful. And I'm happy to mention that we just completed the first vegetation canopy height mapping product with ISAT-2 data that covers the continental US at Lancet-like spatial resolution. So that was the initial vision, and here we are. We have LiDAR from space that keeps improving, data keeps accumulating. It's not only ISAT, it's JEDI as well. So it's really, I think, an exciting moment to do vegetation science with LiDAR from space.
Yeah, I mean we're so excited and can't wait to see the product, the continental scale vegetation product from you. We're really excited about that. And yeah, and you mentioned, starting off in the late 1990s, and the technology, basically that spaceborne LiDAR, was kind of like a dream then. And then, to see how that changed from the late 90s to what you mentioned, 2003, when ISAT-2 went into ISAT-1 went into space, and then how it changed when they were building ISAT-2, how the technology became even more advanced. We were able to fire a lot more photons, 10,000 laser pulses per second, so in 2018 when that was launched, and yeah, I was at the launch too, and it was a great, super early morning launch, a little cloudy, I remember, but it was a really cool launch to be there and see. And I also, you were talking about, you were, a little worried about seeing that first bit of data, that first light of data, come out. I was too, even though I realized how nervous I was just watching the last Delta II rocket carrying ISAT-2, into orbit. That was, very exciting, but, very nerve-wracking at the same time. Something that, you and I have both worked on for a long period of time in different aspects, of course. But yeah, I mean, I love that the vision, bringing the vision all the way back to, the late 1990s and to what you're doing today, and going from there all the way to creating this, continental map of vegetation from space. So, with that said, students with the Trees Around the Globe Student Research Campaign, and, all over the globe program, who submit projects, for judging to the International Virtual Science Symposia, and, in their local schools and regions and towns, they often have a difficulty thinking of, what do I want to research? How do I come up with research questions? And I know, with the work that you're doing, you have, probably come up with so many research questions over your career so far. So any suggestions as to, what students really need to think about when they're trying to come up with research? Should it be something that they really like, or something that they see that's cutting edge that they don't know about and they want to know more about? What are your thoughts on that, Sorin?
Yeah, so I would start with the basics first. So the initial question that I had in mind was, can we actually measure trees with LiDAR? So, and that was the overarching question of my dissertation. And indeed, we can do that. It has been proven, it's a proven technology. And with this type of technology, whether from air or space, we can identify, locate in 3D space, and directly measure three dimensions, vegetation dimensions such as height. Uh, Depending on the type of data, we can also attempt to measure crown size, percent canopy cover. Um, but more than just those directly measured dimensions, we can infer other biophysical parameters, such as tree volume. That's for commercial purposes.
Mhm.
But for other ecological interest, leaf area index, and the holy grail, so to speak, would be the above ground biomass and carbon.
Yeah.
So another question I have been preoccupied with was, what is the relationship between vegetation 3D structure and forest fuels, both surface and canopy fuels? We see a lot of uh, issues with fires,
Mhm.
wildland fires these days. In fact, fires are burning in North Texas these days. I even have a family member that lost their home last night in such a fire,
Oh
which
no.
is it's the first ever. So uh, fires do affect us in multiple ways and change our environment. And I think it's another important question, not just about the biomass that's standing above ground, but what's the changing fuel types, the accumulation of fuels, and what is their contribution, I mean, the contribution of wildland fires to the global carbon cycle. So, and how even they affect our weather. So lots of important questions that start from the most basic one on how we can measure trees and vegetation with LiDAR, but then later evolve into many other questions. And the questions are relevant no matter the scale, but obviously with spaceborne LiDAR, we look at the global um, scale. So we have new research questions that could be formulated, like what is the contribution of vegetation to national carbon inventories, for example? How are the forests changing in response to environmental and human factors? And given all the missions that NASA and other space agencies launch these days, it's how can we improve the accuracy and precision of vegetation inventories to better understand how they're changing in response to climate and human factors. So lots of questions, and I'm sure students can find something that's relevant for their interest.
I like that you started off with, go for the basics first, because when you start off with those basic research questions, a lot of other questions pop up. When we're talking about, LiDAR and using lasers, we're measuring the height from space, but then that height measurement can be then translated into other things, like you mentioned, above ground biomass, or, carbon, how much carbon sequestration trees are pulling in, and lots of other observations that you can get. And you mentioned the whole, precision and accuracy. That's one of the things that we work on with the Globe Observer app, is that we create these data quality flags, and we try to make the app, and the guidance for using the app and looking at measuring tree height using like a cell phone or a tablet. We constantly are trying to improve that, because we want that accurate data. We want that accurate data that we get from ISAT-2 or JEDI. But we want to be able for the people to actually look. They look from the ground up at the tree, when ISAT-2 is looking from space down at the tree. And we also like combining observations as well. When we have the students take tree height measurements, we say, hey, go take a land cover observation as well, because we'd like to know, what is going on. Because with the land cover observation on the globe observer, you take a photograph in all four cardinal directions, but then you also, when you're standing at the base of a tree, you take an up photo so you can see the understory of that tree, which basically ISAT-2 won't be able to see. They're bouncing off the top of those trees. But then also we're able to see a down photo where we can see what the ground and the root structure of these trees look like as well. So a combination of what they're doing, looking at the data with ISAT-2, and then using the globe observer data, we're trying to get a much more precise, much more detailed picture of what we're actually looking at when we're looking at a single tree or a forest of trees. So we're really doing it. But back to basics is, I really like that. I like that idea of starting with the basics, and then other questions will pop up, ones that are extremely relevant and that tie in directly to that original question. So I have one more question for you. Do you have, since we have lots of students who are going to be hearing this, lots of educators are going to be hearing this and seeing this, and as part of their research process, do you have any like words of encouragement for students doing research? Whether it be on their own or with their classmates, or even people around the world. We have students who, are in the United States working directly with students in Africa, or ones in countries in Europe like Croatia or Ireland, working with, students in Thailand and the Philippines, all doing this in the pursuit of science to understand their local environment by taking local observations, so then they can compare these globally. So any final words of encouragement before we end today?
Yeah, I have a few that pop into my mind. So first, I would say follow or discover your passion or a subject area that really interests you. And I'm hoping that that area would have something to do with observing our home, our planet, and its vegetation. Uh, I looking back at what my career has been, I think it's been a joy to work with terrestrial observations from space, and to um, analyze vegetation, to look at our environment, to be able to better and better see at different scales what vegetation looks like. And I do remember one of the first you know data visualizations that many of the scientists involved with ISAC-2 were displaying, was something close to their home, something close to an area that they were familiar with. So observing our home from space, it's really my passion, and I'm hoping that students would discover that as well, and would pursue it to really better, such observations. Second, I'm thinking back at my opportunity with NASA when I was in my not last, but second to last year of PhD studies, when I got to participate in the graduate summer program, graduate student summer program at NASA, when I worked with the first LiDAR data set. So the advice is get involved and do not miss educational and research opportunities that could, in fact, shape your entire career. So look at NASA opportunities and many others, and just pursue them, because you never know how they may change your career and your life in general. And the last one may be, given all the importance of open science these days, citizen science projects such as GLOBE, I say get involved and bring your own contribution. And it is a small maybe contribution, but scaling it up, it does matter in advancing science and observations. So that's pretty much it.
I like that, because that last statement especially was great, because even though, making a small contribution, those single measurements that they're taking in their local environment, whether it's outside their home or their school, or maybe they're on vacation somewhere and taking a tree at observation, every one of those measurements matter. They help us understand our planet a little better, how much our planet is, how it's responding to a changing climate all the time. So thank you for those words of encouragement, Dr. Popescu, and thank you for joining us today.
Sure. Thank you for having me. Appreciate the opportunity.